Before I will go over the problems, I'm going to go over a series of steps that will be useful in solving these problems. The first step is to read the question, sketch a picture if necessary, and define the variables. The variables are the quantities we are asked to find. Once we've defined those variables, we're going to look for a formula for the objective function. The objective function is whatever we're going to try to maximize or minimize. And we're going to identify any constraints. Constraints are relationships between the variables that have to be true. We need to have enough constraints to eliminate all but one of the variables. So if we have 2 variables, we need 1 constraint, so we can eliminate one of the variables. If we have 3 variables, we need 2 constraints, etc. So we always need to find more constraints until we have enough constraints to eliminate all but one of the variables. Then what we're going to do is we're going to solve each constraint for a different variable. We're going to plug them into the objective function, and we're going to limit all but one variable. So the objective function is going to become a function of one variable, an f of x. Once we've done that, we can take the derivative of that function of one variable. Taking the derivative, we can find the critical numbers. Usually there will only be one critical number that makes sense. Again, makes sense basically means we're not going to have a length that's negative. Lengths that negative don't make sense. Usually there's only going to be one of those critical numbers that actually makes sense. Once we've found these critical numbers, we're going to use the critical numbers to find the maximum or minimum. We're going to use either the closed interval method, or we're going to use the first or second derivative test. Basically, we can use the closed interval method if the interval is closed. If the interval is open, we use the first or second derivative test. If there's only one critical number and it's a local maximum, it's an absolute maximum, etc. Once we've done this, we're going to need to state the answer to the problem in words. If the problem is phrased in words, we want to answer it in words. It's important here to reread the original question to make sure you've answered with the right information. Some questions, the answer will be basically the x-coordinate of the point you found. In other questions, it'll be the y-coordinate you have to give as the answer. Problems which involve finding a point which is closest or farthest from a point to another curve involve minimizing or maximizing the distance. The following formulas may be useful for this. The vertical distance is the difference between the y-coordinates, the horizontal distance is the difference between the x-coordinates, and for the diagonal distance we're going to basically use Pythagoras Theorem here. So example 1, we want to find the point on the parabola, y equals square root of x plus 2, which is closest to the origin, which is the point 0, 0. So in this case, this 0, let's call this x1, this 0 is y1, this y is y2, and this x is x2. So basically y2 is y, x2 is x, those are my 2 variables. Well, the distance d is going to be the square root of x2, which is x, minus 1, x1 is 0, so x squared plus y2 is y, minus y1 is 0 is y squared. Now, this is a formula with 2 variables in it. We want to eliminate one of the variables, so we're going to use this equation, which is what's called a constraint. So we do this, we have an x squared plus the y is going to be square root of x plus 2 squared. This basically gives you square root of x squared plus x plus 2. Now we could try maximizing this d here. However, if we take d squared, it'll make the formula simpler. And the maximum value of d squared will also occur at the same x value, which gives you the maximum value of d. So d squared here is going to be x squared plus x plus 2, and that's what we're going to call our function f of x. We can take the derivative, f prime of x is going to be 2x plus 1. When is it 0? F prime of x is 0 when x equals negative 1/2. So x is negative 1/2. That is the critical number. Now, our domain here are possible x values, the interval in question. The domain of this is all the numbers from negative 2 to infinity. This is not a closed interval, it doesn't include both endpoints, so we cannot use the closed interval method. So what we're going to do is we're going to check if this is a local maximum or a local minimum. Because it's the only critical number, it's therefore got to be an absolute maximum or an absolute minimum. So check if it's a local maximum, we're going to use the second derivative test. The second derivative of this thing is 2, this is positive, so therefore this x value, this is an absolute minimum because it's positive. So this is the closest point, one with the minimum distance. The point in question, the point which is closest is this x-coordinate, negative 1/2, and the y-coordinate is going to be square root of negative 1/2 plus 2, which is square root of 1.5.